So we'll digest this in steps. On the x-axis, again, you've got dates, and it doesn't matter what year, it always looks the same. This is April through July, and this is the number of juveniles we get a day in that trap I just showed you next to the cement weir. Basically, if you address this in chunks, this first group here are 2-year-olds. Nadine said that when fish essentially hit their second birthday, they go through a physiological process called smoltification, meaning they imprint on the stream that they're residing on, and then they head out to Lake Superior to grow up. So early on, once fish hit their second birthday, in April, they'll basically all the 2-year-olds will leave the stream and go out to grow up. Then if you're just looking at the gray bars here, these are all 1-year-olds. And now we have to figure out why they're all leaving. And as I said, when stream flows get low, the water gets hot, and they're searching for a place to live. So you can look at the discharge, and in April the water's pretty cool, but come May and June we start getting some warm days. You can see we got a rain event, and then the water started going down a lot, and basically if you're a juvenile steelhead living upstream, you see your world shrinking, and you're trying to find a place to live. And all the individuals which left didn't. They said, I don't have a place to live, and there's no habitat left because the water's going down and it's getting warmer, and there might be enough fish hanging out by all the little springs that they needed to go find another spot. So they end up leaving prematurely, which means that their likelihood of coming back as an adult decreases a lot. So again, then we got some good rainstorms, and you can notice down here, everybody stayed upstream and they were all happy, and they had found a place to live. And then you see by late June, the water starts going down, and at the same time warming up. And all of these 1-year-olds bailed out early because they didn't have a spot to live. So protecting wetlands, protecting riparian areas are all very key things to keeping our fish upstream where they need to be until they grow up. This is a similar graph. On the x-axis is temperature, and units don't really matter. On the y-axis is the percentage of fish that emigrate in May and June when the water levels start going down compared to the entire year. So I realize this is a little complex, but the moral of the story is when you get, the warmer the water gets, which obviously this is cold water and this is warm water, so the more over here you get on the graph, the higher percentage of fish bail out early, because the warmer the water gets, it doesn't matter what year it is, they just can't tolerate warm, low flows. So we need to keep water upstream in our streams. So survival strategies, as I said, a lot of these little guys leave at age 1 early or prematurely when we need them to stay in the streams 2 years. It's essentially, say, sending a kid to college at age 10 as opposed to 18. I mean, they're just not ready, for lack of a better analogy. So when we look around Lake Superior, this is the Minnesota shoreline here. And although this is relatively deep water, you'll see that we really don't have any bays or kind of transitional habitat. That if these 1-year-olds leave prematurely, they don't have anywhere to go. Basically, on the Minnesota shore, this drops off into hundreds and hundreds of feet really quick. And there are a lot of predators out there waiting for them. Where if you look at other areas of Lake Superior, whether you're, this would be Ashland and Bayfield, and well, this would be the Fossil Islands and the UP. In the Canadian bays, a lot of the geology around Lake Superior is very, very similar, at least on the true north shore of the lake, where the Canadians have groundwater issues, they have bedrock substrate. But the big difference is their 1-year-olds, if they get forced out of their stream prematurely, they end up going into, this is Thunder Black and Nipigon Bay. They go into these large transitional kind of estuary type habitats that are kind of a lake within themselves, and they have a much higher likelihood of surviving in those environments as opposed to our shoreline where they basically drop off into the abyss. So the point I tried to make here is we don't have a lot of bay type habitat. If you drive up the shore, you've been to two harbors, there's two little bays, or you've driven around Stony Point just up the shore, there's little bays around it, but protection of those areas is very, very important on our shore because we're lacking estuary type habitat. So this is some fish data that we've learned from the French River. When an adult steelhead comes back to spawn and it gets caught in that trap, we take scales from it, and fish scales are like rings on a tree. You can cut a tree down and you can look at the concentric rings and count and determine how old the tree is. And a fish scale is the exact same, where basically we can tell how many years they spent in the stream and then how many years they spent in the lake. When they're in the stream, they're little tiny guys, so their growth rates are slow. So there'll be two little tight circles in the middle of the scale. And then they go out to the lake at about 8 inches, and within 3 years they come back at 22 to 24 inches. So they grow really fast. So we're able to tell, basically, of all the returning adults, how long they spent in the stream. So we can look at all of our adult scales, which ended up being from 94 to 99 for this slide, and 0% of them left as young of the year or fry or little tiny guys and came back, meaning the fish that leave at that life stage, they're dead. If you left at age 1 prematurely, as I showed you on some of that French River data with the flows, and your likelihood of returning as an adult is only about 0.5%, so 1 in 200. But if you are able, if you have the environmental conditions, have the water, have cool water for 2 or 3 years, your likelihood of coming back as an adult is about 12%, which is good. So retaining our fish in our streams, in our watershed, is very important for what anglers catch. So what anglers catch all starts with the stream conditions, and the stream conditions are very dependent on management of riparian corridors and areas along streams and management of wetlands. So this is the same slide. Now that you just looked at these percentages, just to give you a visual again, this is your age 0 or young of the year. This is a 1-year-old, and this is a 2-year-old. This is about 7 or 8 inches